So today we're going to talk about domain of functions. So last year you should have learned a little bit about domain and range, and domain was probably described as all possible x values. So what that means is any x value that you can plug into an equation and it spits out a y value. It doesn't come out as like undefined. So the only cases where it is going to come out as undefined is in these two cases. One of them is there's an x in the denominator. So if you have an equation like 1 over x, then obviously if x equals 0, 1 divided by 0 is going to be undefined. So that's one case where the domain would have a restriction. And so then the second case is when there's an x under an even root. So the reason is because under an even root, it can, the x can't be negative. So like, for example, if you had the square root of -2, then whenever you type that in, it's going to end up being an imaginary number, and an imaginary number wouldn't be like a real y value. So that would be the reason why there's a restriction when there's an x under an even root, because whatever's under there is going to have to come out to be positive. So like an example of that would be like if you have the square root of x minus 7, then if you tried to do like the function x, or if you tried to do the function and you said that x equals 1, then you would have the square root of 1 minus 7, which is the square root of -6, which is undefined. It would be an imaginary number. And so since you can't do that really, you have to set the radicand, which is the stuff that's under the square root sign, you have to just set that greater than or equal to 0 in this case. And so then you would solve the inequality. And in this one, x would have to be greater than or equal to +7, just so that whatever you plug into that square root sign doesn't come out to be negative. And then the last thing with this is anytime that you're writing a domain, you're going to want to write it in interval notation. So say that you have this domain that you want to write, x is greater than or equal to -7. Then I'm going to just put that on a number line for now. So here's 7, and then it's greater than or equal, so that would be like a closed circle on a number line, and it would shade to the right because that's greater than. So with that being said, sometimes you don't have to put it on a number line. Sometimes it just makes it easier to write it in interval notation. If you can write it from this form, feel free. But in interval notation, since it's a closed circle, that would be a bracket starting at 7 and going off to infinity. So if you need help on how to remember how to write interval notation like this, then let me know. Otherwise, you should be good in writing these domains. So we're just going to go through a few different examples here. Remember that the only two restrictions are when x is in a denominator or under an even root. So in this case, all you have is y equals x squared plus 6x plus 5. There wouldn't be any restrictions in this case. So when there are no restrictions, you guys may remember that means that the domain is allowed to be -infinity to +infinity. And then basically in words, that's just all real numbers is the domain. And so if you write all real numbers, that's okay. But how you want to write that in interval notation would be -infinity to +infinity. So then here is a couple of examples, and we're going to do the first one together. This would be an example where you do have a restriction because you have an x in the denominator. So the method that you're going to use to solve this is you have to set the denominator equal to 0, because then you're going to find the x values that make that denominator 0, and those are the values that cannot work. So we're going to set x squared plus 3x plus 2 equal to 0. And then we have to find where this x squared plus 3x plus 2 equals 0. To do that, you're going to have to factor. So you're looking for two numbers, multiply to 2, add to 3. So that's going to be a positive 2 and a positive 1. And those have to equal 0. So then the method from there is to set each factor equal to 0 and solve for each factor. So x plus 2 equals 0. You would subtract 2 from both sides. And x is going to equal negative 2. Same thing on the other one. Subtract 1 from both sides and x equals negative 1. So remember that these are the numbers you cannot use. So we've solved so far setting the denominator equal to 0. But now we have to go back and write the domain. So that means that x cannot equal these numbers. So then to write the domain, you're going to start with negative infinity. And then the first restriction as you move from left to right, so like the smallest number that you can't use is going to be negative 2. So you're going to go from negative infinity to negative 2. And then you put a parentheses at negative 2 because you don't want to include that in your interval. And then you union, go from negative 2 to negative 1 because we don't want to include that. Union again, and then go from negative 1 all the way up to infinity. So this interval just says you can use any number except for that negative 2 and the negative 1. And that's just because if you plug in a negative 2 or a negative 1, it's going to make that denominator 0. So then you would have 3 divided by 0, which is going to be undefined. Another thing I want to note, I'm not going to go through this entire problem over here, but in this one, instead of having just like a number on the top, you have that 37x. That really isn't going to affect the way that you find the domain of it. You would still set this denominator equal to 0 and then avoid using those numbers essentially. Okay, so the next type of restriction is when you have an x under an even root. So that would be like this, y equals the square root of 3x minus 6. So in that case, you're going to set whatever is under the square root sign greater than or equal to 0. So 3x minus 6 is greater than or equal to 0. And then from there, just go ahead and solve the inequality. So add 6 to both sides. 3x is greater than or equal to 6. Divide by 3. And x is greater than or equal to 2. So then if you have x is greater than or equal to 2, then in interval notation, the domain would read bracket from 2 to infinity. And that would be your domain. Where these get a little bit more tricky is when you have a quadratic under the square root. So then you're going to end up having a quadratic inequality, which can be a little bit different. So we're going to start solving this out. So we're going to start with x squared minus 16 is greater than or equal to 0. So basically what you're going to want to do is go ahead and still factor the quadratic that you have. If you have anything other than 0 on the side whenever you have these, which in this case you shouldn't, but if you ever do, go ahead and subtract that over to the other side, and then you're going to want to factor the quadratic that you have. So x squared minus 16, that's a difference of perfect squares. So that's going to factor to x plus 4 times x minus 4. And then we're not going to worry about the greater than or equal to yet. We're going to go ahead and solve for both of those factors. So we would have x plus 4 equal to 0, x minus 4 equal to 0, and x is going to equal negative 4 and positive 4. So then what we're going to do from there is we're going to use the negative 4 and the positive 4, and we're going to put it on a number line. And from there, we have to use test points. So we know that whatever interval we're using, we want it to be greater than or equal to 0. So if we plug in the negative 4 and the positive 4, then we're going to get 0. That's what we just determined by doing this. So we don't want to use those as our test points. So we need to find numbers that are in each of the intervals less than -4, between -4 and +4, and greater than +4 to determine if each of the intervals is going to be greater than 0 or less than 0. And then we want to include the intervals that are greater than 0 in our answer. So to do that, we're going to use test points. So I'm just going to pick a number in each interval. For less than -4, I'm going to choose -5. For between -4 and +4, I'm just going to go with 0 because that's a typical easy one to do if your two numbers that you have, your two zeros, are one is negative and one is positive. And for above 4, I'm going to go with 5. So then for each of these, I'm going to determine whether it is, like whenever you plug it in, whether it's greater than or less than 0. So our original equation was x squared minus 16. So I'm going to start with -5 squared minus 16. So that is going to equal 25 minus 16, which gives us 9, which is greater than or equal to 0. So since 9 is greater than or equal to 0, we're going to want to use that interval because it satisfies what we wanted to find. So then next I'm going to plug in the 0. So 0 squared minus 16, just going to equal 0 minus 16, which equals -16, which is less than 0, so that one does not work. So we're not going to use that interval in our domain. So the last one is 5 squared minus 16 is 25 minus 16, which is also 9, which is greater than 0. So we do want to use that one. So now anywhere that we put a check mark, that means we want that interval in our domain. And since it's greater than or equal to, we want -4 and +4 as well. So we're going to shade the areas that we have a check mark. And so then as we're writing our domain, the domain that we're going to want goes from -infinity to -4 with a bracket because we want to include -4. And then we're going to union and go from +4 to infinity. So we're leaving out that space between -4 and +4 because whenever you plug in any number between -4 and +4, you're going to get a number that's less than or equal to 0. And then whenever you put that under the square root sign, you're going to get an imaginary number. So if solving the polynomial or quadratic inequalities is a little bit confusing for you, then with using the test points, then there is another way to do that. So I'm on the Desmos graphing calculator right now, and I'm just going to put in the same equation that we just did. So that was x squared minus 16. So then immediately that's going to find your zeros for you. So you can see that you have a 0 at -4 and a 0 at +4. And then in this case, like kind of how to look at it is, you want the pieces of the graph that are greater than 0. So you're going to look for that like positive interval. So you can tell that from -infinity to -4, you're above it. And then from -4 to +4, you're in this negative interval, so that means you're less than 0. And by negative interval, I'm referring to the space that's below this x-axis. And then starting again at 4, it jumps back above the x-axis, and so that's going to be where it is greater than or equal to 0 again, so that's going to be included in your domain. The only thing I will say about using this method is sometimes whenever your factors don't come out to pretty numbers like -4 and +4, Desmos may show you a decimal where we may be using a fraction when we're talking about it, solving it the other way. So just watch out for that, but this is definitely another method you could use if the quadratic inequality method is a little bit confusing for you. Okay, so then the last type of example that I want to do is going to be one like this first one here, where we have an x under an even root in the numerator and we have an x in the denominator. So we're going to have to do both the setting the radicand greater than or equal to 0 and setting the denominator equal to 0. And then I said over here, choose the most restrictive domain. So that kind of just means like include all of the restrictions that are possible in here in your domain. So let's start by doing x squared minus 4 is greater than or equal to 0. So then we're going to factor x squared minus 4. You get x plus 2 and x minus 2. And I wrote that wrong. It should have been greater than or equal to 0. And then you're going to solve out your factors, and you're going to get x equals negative 2 and x equals positive 2. Then you're going to use those to set up your number line. And you have to find test points to use for each of them. So my test points I'm going to do are going to be negative 3, 0, and positive 3. So I'm going to come over here and I'm going to do negative 3 squared minus 4, which is going to be 9, minus 4, which is 5, and 5 is greater than or equal to 0. So we want to use that first interval. Second, we're going to do 0. So 0 squared minus 4 is 0, minus 4 is negative 4, and that's less than or equal to 0. So we do not want to use that interval between negative 2 and 2. And lastly, we're going to do 3 squared minus 4, which is 9, minus 4, which is 5, which is greater than or equal to 0. So we do want to use this one. So far, we have our domain including everything from negative infinity to negative 3, or negative 2, and everything from positive 2 off to infinity. However, we still have to figure out if there are any restrictions from that x plus 5. So we're going to also set that equal to 0. And when I say set that equal to 0, I mean really, it cannot equal 0. So then I'm going to subtract 5 from both sides, and I'm going to get that x cannot equal negative 5. So that just adds another restriction right here. So I'm going to kind of draw an open circle and put negative 5. So that just means we need to avoid the number negative 5. So then if we write out our entire domain, then we start at negative infinity, go to the number negative 5 because we can't include it, use a parentheses there, and then we're going to union and start again at negative 5, go to negative 2. At negative 2, we do want to include it, so we put a bracket, then another union. We don't want to include the space between negative 2 and positive 2, so we start again at positive 2 and go to infinity. So this would be our whole domain, and it has multiple restrictions, and it's kind of lengthy to write it out, but that is how you would want to write out this domain. So it's everything less than negative 2 except for that negative 5. You just jump over that by using those parentheses, how we wrote it here, and then everything from positive 2 up to infinity. So anytime that you have both in one equation, make sure that you take into consideration all of the restrictions instead of just some of them. And then the last thing that I want to touch on is whenever you have something like this problem here where you have an x under a square root, so you know that you need to set the 5x minus 3 greater than or equal to 0, but then the square root is also in the denominator. So that means that whenever you set that equal to 0, so if you set that whole thing equal to 0, that couldn't be included either. So the way that you can kind of remedy that situation is you would normally have 5x minus 3 is greater than or equal to 0. However, you don't want it to actually equal 0 in this scenario, and you don't really have to worry about the square root because the square root of 0 is 0, so for it to be 0 in the denominator, the stuff under the square root would also need to be 0. So what you do in this situation is just get rid of the equal to sign. And so 5x minus 3 would just need to be greater than 0 because it can't be 0 because it's also in a denominator. So then you would just solve from there. So add 3 to both sides. And you would want 5x to be greater than 3, and then divide by 5. And you would want x to be greater than 3/5. And so then whenever you're writing that in interval notation, just make sure you use a parentheses starting with 3/5 and go to infinity. And that would be it. So just watch out for that and make sure that you don't use a bracket in this scenario whenever you have that square root in the denominator instead of the numerator. So if you have any questions about domain, please ask them during class. I know this was a lengthy video. I know this is like a very dense subject to talk about. So please let me know during class if you have any questions, and go ahead and start practicing how to find these domains on that assignment that I posted. And if you have any questions on that as well, please just email me, message me through Remind, or come to class and ask questions because I am here to help with this. I know this can be a tricky subject to cover, so good luck in finding your domains.